All right, so in the this part, we're going to go through and talk about release detection, and that's determining whether we've had a release of the regulated substances occurred either into that interstitial space or it has occurred into the environment. One of the two. So you must be able to detect a release from any portion of the tank or the underground piping that routinely contains product. Important little concept here. You must be able to detect a release from any portion of the tank or underground piping that routinely contains product. Release detection. Regardless of what you're using at your facilities to do release detection, it has to be installed, it has to be calibrated, it has to be operated and maintained according to the manufacturer's instructions. You also have to have documentation that whatever release detection method that you're using can meet the performance requirements. Now, when we're going to talk about release detection, three important numbers here. One is 0.2, that's 0.2 gallon per hour leak rate. That is your monthly release detection rate that you've got to meet, 0.2 gallons per hour. The second number that's important while we're talking about release detection is 0.1 gallons per hour, and that's for tank tightness or tightness testing. The third important number for release detection is 3.0 gallon per hour leak rate, which is for the catastrophic leak rate if you have pressurized piping for your automatic or your electronic line leak detectors. And we're going to get into all those numbers, but pretty important numbers. 0.1 tightness testing, 0.2 is your monthly release detection method that you have to meet, and then the 3.0 gallon per hour leak rate if you have pressurized piping, the catastrophic leak rate for automatic or electronic line leak detectors. So if each one of these things that we're going to be talking about as far as release detection, and I think this is on page 28, and it shows this national work group for leak site. Yeah, and so, you know, this is really good for all you people that have automatic tank gauges. For you to run a valid release detection test, you have to have X amount of product has to be in your tanks. And you know, when gas prices were really high here in the state of Arkansas, we had a bunch of people that had automatic tank gauges that would run their monthly release detection tests through their automatic tank gauge where they wouldn't have enough product in the particular tank to make it a valid release detection for the month. And this is where you can find this out, is on this National Work Group for Leak Detection site. And not only, you know, does Veeder-Root or the different types of people that are out there that manufacture these release detection equipment, these guys, not only does Veeder-Root tell you that they'll work, but these guys actually, they third-party certify what the other people out there say that their pieces of equipment will do. So you can go out on here and find from automatic line leak detectors, electronic line leak detectors, automatic tank gauges, or any of that stuff. You can go to this website. You can look to see what you have at your facility, and this will third-party certify that your equipment will do that release detection at those numbers, the 0.1 or the 0.2 gallon per hour leak rate. So it's an important site. It shows the test method index that can be used. If you're going to be using, you know, for a tank tightness test, it will tell you what method that they're using. Has it been third-party certified if you don't have an automatic tank gauge? So, but anyway, it's a site that you need to be familiar with, and especially if you have an automatic tank gauge. It's going to give you how much product that you need to have in your tank before you have a valid monthly release detection test. So I want you to look at all these release detection methods that you're seeing here. And these are monthly release detection methods. So you have to run at least one of these tests a month. You've got to keep the last 12 months of these records. So you guys that are Bs, important part here, record keeping when it comes to release detection. Just look, just get a visual of what you're seeing there. It doesn't matter what it is. They're going to ask you any of these. How long do you have to keep the records? You've got to keep them for 12 months. How often do you have to do these tests? You have to do these tests once, at least once per month. You got to keep the last 12 months of records. You get 3 or 4 questions right on the test if you keep that in mind. So, unfortunately, we're going to talk about each and every one of these release detection methods: automatic tank gauging, interstitial monitoring. So we're talking there about secondary containment with interstitial monitoring, statistical inventory reconciliation, continuous in-tank leak detection, vapor and groundwater monitoring, inventory control with tank tightness testing, and manual tank gauging. Now, of these release detection methods up here, there's 3 of them that don't have to do with inventory control. And what I'm talking about inventory control is you got to balance that checkbook each day between what you've got coming into your tank versus what goes out of your tank. So inventory control. Now there's 3 methods up here that don't use some form of that inventory control, and that is vapor and groundwater monitoring, and the other one is the interstitial monitoring. So what you're doing here with the interstitial monitoring, you're measuring that space in between, in the secondary containment portion of tank within a tank, pipe within a pipe. You're measuring that space. And then the vapor and groundwater monitoring, you're actually measuring for vapors in those. So, and then you're measuring for groundwater sitting on top of the groundwater down below your tank. So those are the only 3 release detection methods that are not out there where you're not using some form of inventory control. You know, what you got product coming into your tank versus what you got going out of your tank. So this shows just a little setup here of all the release detection methods that are out there. You can see here's the vapor and the groundwater monitoring. Now both of these are done in wells that are on your site. Here you can see secondary containment, and this is monitoring that interstitial space between the inner tank wall and this outer tank wall. You can see inventory control and manual tank gauging, where you have a guy that's actually taking inventory control with the gauge stick. The same thing is happening here for automatic tank gauge, where you have a probe that goes directly into the tank. And it's doing your inventory control for you directly into the tank. Here you have your tank tightness test and your line leak detectors. And if you have a line leak detector, it indicates that you have pressurized piping. So just a little gauge there, or a picture of what's actually out there. And this is what we already talked about. These tests, these monthly release detection tests have to be performed every 30 days, and you've got to keep the last 12 months of these records. So the first of the release detection methods that are out there is we're going to talk about is the automatic tank gauging systems. Now, basically what's happening here, this is inventory control, but it's being done by a machine that has a probe that goes directly into your underground storage tank. And these automatic tank gauge systems, they continuously collect information. They do the product level that you have into your tank, and they also measure the temperature of the material that's in the tank so that they can come up with a pretty precise volume of product that you have inside this tank. Right, it's done by this probe. And if you're using this automatic tank gauge system, again, monthly release detection here, this particular box has to meet that 0.2 gallon per hour leak rate. So what actually happens here, you can go on that National Work Group site, you can go in there, you can pull up INCON, you can go in there to the model number, the TS2000, you can go in there, you can pull it up, and it's going to tell you, third-party certified, that this box will do this 0.2 gallon per hour leak rate. It'll also tell you if it might do, if the probe is sensitive enough where it'll do a 0.1 gallon per hour leak rate to do a tightness test for your system. So this is where you can find out what the particular probes can do in these automatic tank gauge systems. But that 0.2 gallon per hour leak rate, it's basically 24 ounces of product leaking from your system in a 1 hour period. So pretty delicate little device when you get right down to it. So on those automatic tank gauge, in the probe that goes directly into your tank, this is what the probes look like. The bottom probe down here, it measures the amount of water that you have in your tank. The second probe measures, or the second float that you're seeing here, it's measuring the amount of product that you have within that tank. And then there's also a temperature probe that's in there that sets you up so that you have an accurate amount of volume that's inside that tank. Now, you know, we're talking about release detection here when we use inventory control. If you can't balance versus what goes in versus what goes out, you're going to fail these inventory control based release detection methods. So these are important that, you know, you get accurate data. So this is what the ATG probes look like. They sit right up on top of the tank and they go directly into the tank. This is the only release detection method that has something that goes directly into the tank, is the automatic tank gauge system. So, and you can see here's two older, this is automatic tank gauge going right into the backfill on top of the tank, two older kind of setups, and this is a more modern and a newer setup for an automatic tank gauge where it's inside a self-contained sump where you can get to it. So what you need to know about automatic tank gauges, like I said, depending on the probe that you have in that automatic tank gauge, some of them can perform that tank tightness test, which will go down to that 0.1 gallon per hour leak rate. So nice little box here. And you know, whenever you run the test, it'll run out a strip of paper that'll sit out there and say you have passed your monthly release detection method or passed the 0.2 gallon per hour leak rate. So, you know, most of the people that have automatic tank gauges, they set them up to run this test like 5 days a week at like 7 o'clock in the morning. You know, when you got some quiet time at your tank. Yeah. So these things generally run these tests at a, you know, sometime early in the morning when the tank is as quiet as it's going to be during the day. And then you're going to get an accurate volume reading or accurate volume of product that you have inside your tank. So, and this is what I was saying about when gasoline prices were really high, is people that had automatic tank gauges were actually getting a slip of paper that would come out of the automatic tank gauge that said that they had passed their monthly release detection test. However, they found out that those weren't valid tests when they found out that you had to have, your tank had to be, you know, 29% full or 32% full. So when you actually look for a volume, it says all of these require a minimum amount of product inside the tank to conduct a valid test. So we had people that showed that they'd passed their monthly release detection at 0.2 when actually they didn't have enough product in their tank, so it wasn't a valid test. So you must print and keep at least one copy what comes out of your automatic tank gauge. They will collect and electronic data, but you're just one lightning strike away from that wiping out all the data that you have. So that's why they ask you to go ahead and print and copy at least one of these per month to show that you've done this test. So this is what we talked about in one of the first couple of slides this morning. If you have an automatic tank gauge, you need to pay attention to any and all alarms. If those alarms go off, you don't go and just shut them off just because you're inconveniencing the people that are at your station filling up. You find out why that they're going off and you fix them. You have to respond appropriately to the alarms, and then you got to report all suspected releases to ADEQ within 24 hours. And that's really important if you want to use the Petroleum Storage Tank Trust Fund. So anytime that you have a suspected release, you need to call us. And and let me point out here too, that if you have a release or if you have a spill at your facility, that's not a violation. The violation is what happens, what you do in the next 24 hours. And in that next 24 hours, we've got to be notified. So don't let that be a part of how you can take part in the Petroleum Storage Tank Trust Fund, because you're not getting on the phone and notifying us within 24 hours of a suspected release or a spill. So get on the phone. Don't hesitate. Never ignore your automatic tank gauge alarms. Find out if they're going off, find out why they're going off, and fix them. Okay, the second form of monthly release detection here is secondary containment with interstitial monitoring. Okay? Secondary containment, one more time, is that you have an additional barrier on the outside. You have a secondarily contained zone that in case you have a breakthrough from the pipe, that you have another way to catch whatever leaks through that inner wall before it can get to the environment. And what's good about that is that you can monitor that space. It makes it easier to clean up if you've had a breach of the inner wall. It also lets you show what kind of substance that you have in that secondarily contained area and how much. So you can have a barrier outside the tank or a piping, and some of those examples would be like a double-walled tank system. That's what we're talking about. The jacketed steel tank is a double-walled, well, it actually has a jacket. Instead of being a tank within a tank, there's a jacket on the outside of that tank. But it has a form of secondary containment in. Or you can have, like what we talked about earlier, this bladder inside the tank, which is not all that common anymore. It's like an internal lining of the tank. So for the interstitial monitoring portion of this, and this is another one of these forms where we're not using a form of inventory control, we're trying to find released product in this space. So you have to monitor the area between the tank and the piping and that secondary barrier for releases. That space, you can it can be monitored either manually or electronically. And you have to be capable of detecting a release from the inner tank wall into that secondarily contained space. So when we're talking about interstitial monitoring here with this particular tank, this is the space that we're actually monitoring, is that space that you're seeing right there. If you have a release from the inside of this tank, that release will get caught in that interstitial space. You'll be able to monitor it in that interstitial space. And you'll also be able to, if this tank is sitting in some groundwater, if you had a release from this outer tank wall, you'll be able to find it in that interstitial space. And some of these automatic tank gauge sensors that are at a part of these things, they can determine whether it is water or whether it is gasoline in that interstitial space. So that way then you can determine whether you got an issue with your inner tank wall or your outer tank wall. So also you can have a tank pit excavation liner. In a case, let's just say if you had a tank pit excavation liner, let's just say this is the excavation zone for your tank. And let's say that your tank is sitting in the middle of this. If you had this, what they're talking about here is if you have an excavation liner, you could take a line, this could be the liner, and this liner could go inside of this excavation zone. And what they're talking about here, this could be a form of secondary containment, where the wells have to be inside this pit liner for you to be in here to monitor the interstitial space, because the liner would be your secondary containment form here. So you got a single walled tank. Before the stuff can get to the environment, it would be caught inside here by this liner inside this tank. So that liner then turns into your secondary containment. And then for you to monitor the interstitial space, then those wells have to be inside that liner. Make sense? It's the same thing like in this case here, if we had a tank within a tank, if you're monitoring the interstitial space here with an automatic tank gauge, it's the same thing. This thing here is monitored from a release coming from here into that space, or from the groundwater that's in here on the outside of here, getting into that interstitial space right there. So, when we talk about secondary containment, don't just, you have to think along the lines, or that could also be a sump, where you could have some piping that's actually you could have some piping slope back into a sump, instead of have this being a liner. This is like one of those sumps that we saw. And then you're going to have that, where does that sump sensor have to be located? Is close to the bottom down here, because you want to have this amount of product and you want to have that sensor go off to let you know. But we'll talk about that in a minute. But I just wanted to point out that you need to think in the line of tank within a tank or pipe within a pipe, but it also can be, you can also have a liner. And what I'm saying is you're monitoring that interstitial space as long as the wells are inside of that liner.
How would you handle stormwater in case that doesn't work? I mean, if you have a big rain event, wouldn't it fill up that?
Yep. And and once you get inside one of those situations like that, then it's also going to try and lift that tank up out of the ground. And there's a bunch of those things when we had that stuff with Katrina. There were so many underground tanks that just come blowing up out of the ground due to the buoyant forces of the water down there just picking and lifting them up. I mean, just bust the concrete and get them on the surface. So, but anyway, it's just another form when you're thinking about this. There's another with an actual liner inside there, and how you're going to monitor that interstitial space is inside that liner, between the tank and that liner. So we talked about this once earlier today, and that's about anything that's been put into the ground after July 1, 2007. You have to have any tanks or piping have to be secondarily contained, and you have to have a way to monitor that interstitial space. Anything in the ground after July 1, 2007. So if you're using electronic sensors, you have to check those sensors according to the manufacturer's recommendation for electronic sensors sensing that interstitial space. If you're using a liquid-filled or sealed pressure vacuum system, you have to make sure that system is within the manufacturer's tolerances. So there's a bunch of ways that you can do it with a probe. You can do it with liquid-filled or sealed pressure vacuum systems can be used to monitor that interstitial space. And here's what we were talking about here earlier about, here's where the sump sensor, where does this sump sensor with secondarily contained piping, where does it need to be located? And here is that sump sensor that you're going to see right here. So we have secondarily contained pipe that you can see just barely here, and that pipe is sloped back into this sump, so it's working just like what we're seeing here with this excavation liner. And so they're going to ask you, where does that sump sensor, where does it need to be located? It needs to be located as close to the bottom of that sump, so if you got product in that sump, you got line leaks, that it's going to set off that at when there's 1/8 of an inch of product in there, versus if you don't set it on the bottom, you set it up here, then it's not going to set off that alarm until you've got 6 inches of product in there. So you want it to trip that mechanism as soon as when you got a minimal amount of product that's actually in there. So all right, now the third method of monthly release detection is statistical inventory reconciliation. Now this is basically inventory control again, except with this inventory control, the raw data that you're using whenever you're sticking or whatever your tank on a daily basis, you're going to take this raw data and you're going to put it into a computer program. Or either that, or you're going to send this raw data to one of these statistical inventory reconciliation providers. They're going to put the raw data into the thing, and then they're going to send you whether you passed, failed, or whether you have an inconclusive result using this particular method of release detection. So some of the statistical inventory reconciliation methods can be used, again, like the 0.1 gallon per hour leak rate for your tank tightness testing. So, and then you can also find that particular things out on that National Work Group website for testing methods. So you do your daily 1/8 of an inch measurements, whether you use an automatic tank gauge or you're sticking your tank. You have to take a monthly water reading if you're doing SIR. Now, also if you're doing SIR, it requires that your meters have to be calibrated, because if you're not dispensing a gallon of gas, then you're not going to be able to balance this checkbook when it comes up to pass, fail, or inconclusive using this method. So, you don't want to be dispensing 0.96 or 1.02 of gasoline, because you're never going to be able to balance this checkbook out for inventory control. So requires annual meter calibration at least, and then it requires deliveries through those drop tubes, and remember, 4 inches from the bottom of the tank for SIR. So, like I said, SIR can be conducted by a vendor for the tank owner, or you can buy an SIR program and then you can put in the raw data yourself. It's basically inventory control that turns into the raw data that goes into a computer program that does your monthly release detection. So in this particular case, your results can be reported as either pass, fail, or inconclusive. And when you're using SIR, this is for release detection, not only for your tanks, but also for piping at the same time. So you got to keep your complete SIR records, and that includes all the raw data that you added into the computer program that then spit out whether you passed, failed, or had an inconclusive result for that month. If you fail your monthly release detection with statistical inventory reconciliation, you have to report it to the department within 24 hours as a suspected release. And then you're not done. You have to either confirm or deny that you had that release within 7 days. Important point there. You fail, 24 hours, call. Then you got 7 days to either confirm or deny that you had this suspected release. Then 7 days. If you get an inconclusive using SIR, It has to be investigated immediately and it has to be resolved. In most instances, if you get an inconclusive, you need to calibrate your meters, and if you don't have, or either that or you need to do a better job sticking your tanks. Generally, that's the two cases. Uncalibrated meters or a bad job of sticking your tank will get you an inconclusive. If you can't resolve the inconclusive after you investigate, then it has to be reported to us within a 24-hour period as a suspected release from your facility. So that's inconclusive. Now, if you get an inconclusive, it basically means that you have no release detection for that month. If you get an inconclusive in 2 consecutive months with an inconclusive, it is a suspected release. That has to be reported to us within 24 hours. 2 consecutive months of inconclusive is a suspected release. You have to investigate, you have to determine the reasons and correct any of the causes for an inconclusive result. Tell you one more time, monthly release detection method, you've got to keep the last 12 months of these records. All of these release detections, 1 a month, last 12 months of records. So, one more time, what should you do if you receive an SIR inconclusive monthly result? SIR inconclusive. You have to investigate and correct any sources of the error found. You can consult with the vendor for any suggestions that he might have how to fix the problem. But like I said, in most cases, you got, if you're going to see it on a month-to-month basis, you need to go and see if get your meters calibrated. What do you do if you get your second consecutive monthly SIR inconclusive result? You got to investigate as before. However, this time you have to call us and tell us that you've got a suspected release at your facility. 2 inconclusive in consecutive months. All right, now, there's not anything on this test about this form of release detection, but this continuous in-tank leak detection method is for facilities that do more than 1 million gallons of throughput a month. 1 million gallons a month. So in these instances, that means 1 million gallons a month, that means that you're dispensing 14 gallons of fuel every minute, every day of the month. 14 gallons, that's 1 million gallons. Some of these release detection methods for these big truck stops go up to like 2.75 million gallons a month of monthly flow through a facility. A lot of gas, a bunch of gas. Well, in all these instances, you know that in the other forms of release detection, we were doing it when the tank was doing in its quiet time. Well, you can tell if you're pumping at least 14 gallons every minute of every single day in the month that there is no quiet time in these tanks. So they had to come up with a way to do a monthly release detection. So both of these methods that we're going to talk about here, no quiet time in the tank, and you got all this stuff is all hooked up to a processor, to a computer, to your point of sale systems, and they are continuously running leak detection every second of every day to see if you've had a release. But the first one is the in-tank leak detection is the continuous automatic tank gauge. And automatic tank gauge is just like what we were talking about for our monthly release detection for the tanks. This is for the tank and the tank only, tank gauge, continuous in-tank leak. So it's using inventory control, and it's putting it into a processor, putting it into a computer program, and it's running continuously your leak detection at these high flow throughput facilities. The second form is continuous reconciliation. It's just like statistical inventory reconciliation. it's doing leak detection for both the tanks and the piping at high flow throughput facilities. So that's all that you really need to know about. You just need to know that they had to come up with a method because there's no extended shutdown at these particular facilities. And so they had to come up with a way to do release detection, and this was what it is. And you know, basically everything at the facility is all hooked together. It's continuously looking for a release of that 0.2 gallon per hour leak rate. So now here is a second, and what you need to remember here about both vapor monitoring and groundwater monitoring is that both of them require a site assessment before you can use them for a monthly release detection. These particular, both vapor and groundwater monitoring, don't use any form of inventory control to see if you've had a release. So what's important though about vapor monitoring, number one is vapor monitoring does not work well with a product that does not vaporize easily. So if you're only selling diesel fuel or you only got waste oil at your facility, then vapor monitoring is not the way for you to go, because you have to have gasoline or something that vaporizes it so the equipment can pick up those vapors to indicate that you've had a release. But so if you're going to do vapor monitoring, there's two ways that you can do it. One is you can have a portable handheld device, which you can go to each one of your vapor monitoring wells. You stick the PID or the photoionization detector down into each one of your wells. It pulls an air sample out of there, and if it detects vapor from gasoline, it works just like a Geiger counter. You know, it'll peg out. You can hear it click, 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 click. So you have to go to, if you have 4 or 5 vapor monitoring wells at your site, to use this form of release detection, you have to go down and pull an air sample out of each one of those monitoring wells at least once a month. So if you got 5 sites to do the release detection, you've got to go through all 5 of those wells. So to use vapor monitoring, you must have this site assessment. The site assessment is going to determine whether you can use this as a monthly release detection method. And basically it's 5 hoops that you have to be able to jump through to do vapor monitoring. So you have to have properly installed monitoring wells. That's going to be done by the contractor that puts this in place and does this site assessment. You have to have either that PID or a sensor to actually, from means of measuring the soil vapors. Your backfill material has to allow for the vapor to actually move to the wells where it can be sampled. The stored product that we're trying to find as far as a release has to vaporize enough to where our monitoring equipment can pick it up. You also have to make sure, if you're using vapor monitoring, that any background contamination will not prevent it from picking up any vapors that are in that soil. The number and placement of the monitoring wells is going to be done by the contractor. But you also have to make sure that any groundwater, rainfall, soil moisture, or other interference will not allow a release to go undetected for longer than 30 days. And if you can't do all of these 5 things that are right here, you cannot do vapor monitoring for release detection. So 5 little hoops you got to jump through. Vapor monitoring, you have to keep all your vapor monitoring ports clearly marked and secured. You don't want them not to be clearly marked and secured and have a new driver come out and drop a load of fuel down your vapor monitoring ports. You've got to keep that site assessment for both vapor and groundwater monitoring that shows that you can meet those 5, or in this case of groundwater, these 7 things that are necessary to use these as far as a monthly release detection. So if you're going to do groundwater monitoring, there's 2 methods that you can use. One is a manual method where you actually drop a bailer down the groundwater monitoring well. You drop it down there to where it encounters groundwater. you pull the baler up, you look on top of that groundwater, and if there's any been a release of product that's in there, it's going to be just like vinegar and oil. The gasoline is going to be sitting right up on top of that groundwater, and you'll be able to just pick it up. Just like is in doing the vapor monitoring well, if you're doing groundwater monitoring, you have to put this baler down each one of the groundwater monitoring wells to do this test and to do it right. So if you got 5 wells, you got to drop the baler down all 5 wells and look for a sample to see if there's gasoline sitting on top of the groundwater, indicating you've had a release. Here's a cat on the left. He's dropped that baler down into that monitoring well. He's pulled it up. Now he's actually looking for gasoline sitting on top of that groundwater. There's a sample monitoring well cover that shows that this is a groundwater monitoring well. And they're just like the vapor monitoring wells. You know, it's good to have them secured and well marked because you don't want to have a driver dropping fuel into your groundwater monitoring port. The second method, if you're not using the baler, is that you can have permanently installed electronic sensors that are in the monitoring wells, and they're continuously looking for products sitting on top of the groundwater. And they're attached to your automatic tank gauge. So if you're using groundwater monitoring, just like vapor monitoring, you must have the site assessment, you must have properly installed monitoring wells, and you have to have one of those means, either the baler or electronic sensors, to detect products sitting on top of the groundwater. In that site assessment, very important here, this first thing is that if you're using groundwater as a monthly release detection method, the groundwater can never be more than 20 feet below the surface, never more than 20 feet below the surface. You also have to make sure that the tank pit excavation zone does not encounter any bedrock. If it encounters bedrock, you know, how's that gasoline going to get to the monitoring well? Won't make it. You also have to make sure that the soil is permeable enough for the gas to get to the wells so that you can detect it. Product stored has to be capable of being detected by groundwater monitoring, means that its specific gravity has to be less than 1 so that it sits up on top of the water, the groundwater. So whatever monitoring device you're using to detect products sitting on top of the groundwater monitoring well, it has to detect at least 1/8 of an inch as a minimum, 1/8 of an inch of product on the top of the groundwater. And number 7, the number and the placement of the monitoring wells has to be adequate, and that's going to be done by the contractor that does this site assessment for you, that you've got to keep. And if you can't do these 7 things, then you can't use groundwater monitoring for a monthly release detection method. So somebody's actually going to come out and do the report for you. So you got to, you know, just like I said about the vapor monitoring reports, you need to be clearly marked, they need to be secured. You don't want somebody dropping a load of fuel into your groundwater monitoring ports. All right, now we're going to talk these next 2 things. Inventory control with tank tightness testing. Anytime that you see later on this afternoon when we add, whether it's manual tank gauging or inventory control with tank tightness testing, you can only use these things for a 10-year period. That's it. And in the middle of that 10-year period is when you do the tank tightness tests. So inventory control with tank tightness testing. If you got a tank that goes into the ground in 2002, how long can you do inventory control with tank tightness testing? Until the year 2012. 10 years, that's it. Then you got to go to another form of release detection. So, and it works out the same way. If they ask you about manual tank gauging with tank tightness testing, it's the same thing. You can only do it for 10 years. And in the middle of that 10-year period, you have to do a tank tightness test in year 5. You can only do it for 10 years. So just remember that when you see that later on today, when they've got inventory control with tank tightness testing. And I'll just point out too, that tank tightness testing is not a monthly release detection on its own. It has to be in conjunction with inventory control or manual tank gauging. It's not a release detection on its own. Tank tightness testing. So inventory control, again, is what we're doing. We're measuring what goes in versus what goes out. You got to be able to balance that checkbook. Balance that checkbook, then you have to do a tank tightness test in the 5th year. And you can only do this for 10 years, and then you got to move on to something else for release detection. Inventory control with tank tightness testing. So inventory control, again, using a gauge stick or electronic monitoring device, ATG, to do your inventory control. Same thing, you're measuring what goes in versus what goes out. You got to be able to balance that book. You got to record your inventory and dispenser readings each day. You have to reconcile your deliveries with your delivery receipts. Inventory control. You have to measure water in your tank to the nearest 1/8 of an inch at least once a month for inventory control. You have to reconcile this data every 30 days. It's a monthly release detection. You need to report all suspected releases, and that's within that 24-hour window. So there's a chart that we're going to talk about here. If you're just using straight inventory control for this 10 years, when do you have a suspected release when you're using inventory control? Is when you have 2 consecutive months with daily overages or shortages that are greater than 1% of the total monthly flow through plus or minus 130 gallons. So you get 2 consecutive months with daily overages or shortages that are greater than 1% of total monthly flow through plus or minus that 130 gallons. So as an example here, let's just say that we have 10,000 gallons of monthly throughput through your facility. We take 1% of that 10,000 gallons, that equals 100 gallons. You add the 100 gallons plus or minus the 130 gallons, that means you can pass this form of release detection here if you only lose 229 gallons out of your system per month. Somebody's going to ask you where that stuff's going. But you're still going to meet your release detection if you're less than the 230 gallons on a monthly basis. Now, let's go back and look, while we're talking about this, look what would happen if we had the 1,000,000 gallons from those high flow throughput facilities. You take 1% of those 1,000,000 gallons a month, you're going to come up with that 10,000 gallons. So here, you could pass this form of monthly release detection as long as you didn't release 10,129 gallons worth of gas a month. You could pass this for monthly release detection. And then, you know, you're probably going to get fired. Where did the 10,000 gallons go? But anyway, that goes to show you. But so this is not all that, it's not like the 24 ounces per gallons in an hour, like we saw in some of the other release detection methods. So you have to measure each day the tank is in operation, inventory control again. Your stick measurements have to be reconciled with your book inventory and your sales every 30 days. Inventory control. You can only use for 10 years after installation or a corrosion protection upgrade. And in the middle of that 10-year period, you have to do that tank tightness test. Okay, so anytime you see inventory control with tank tightness test, you can only use it for 10 years. In the middle of that 10-year period, you have to do that tank tightness test. If you're doing a tank tightness test and it's not done by your automatic tank gauge, it has to be conducted by trained ADEQ licensed testers. The method that they use to do that tank tightness test has to be a third-party certified test method. And you can find that out by going to that National Workgroup site and go to tank tightness testing. You have to maintain the results, important here, maintain the results of the tank tightness test until the next test. Tank tightness test. Remember, 0.1 gallon per hour leak rate. All right, so now we're going to talk about manual tank gauging. The manual tank gauging is the last of the monthly release detection. A lot of people are not using manual tank gauging for this first reason, is that the tank has to be taken out of service. The tank has to be taken out of service for a minimum length of time of 36 hours. Depending on the diameter of the tank, you might have to take this tank out of service for 54 hours, but at a minimum, 36 hours is required for the tank to be out of service. The product level has to be measured and the readings have to be compared to both weekly and monthly standards. So again, manual tank gauging, you're doing inventory control, you're taking stick measurements to the nearest 1/8 of an inch in the tanks. For manual tank gauging, it can only be used for tanks that are between 1,000 and 2,000 gallons. 1,000 and 2,000 gallons. And you have to do a tank tightness test. Manual tank gauging, tank tightness test. Again, 10-year period. In the middle of that 10-year period, you have to do the tank tightness test. But if you're using manual tank gauging, it can only be done for the tanks between 1,000 and not larger than 2,000 gallons. Manual tank gauging with tank tightness testing can be used on tanks between 1,000 and 2,000 gallons. In the middle of the 10-year period, you have to do a tank tightness test. If your tank is larger than 2,000 gallons, you cannot use manual tank gauging with tank tightness testing. If your tank is below 1,000 gallons, you can use manual tank gauging, and tank tightness testing is not required. So what you do, you determine the length of the weekly test, and you remove the tank from service. For that, like I said, it can be 36 hours, it can go up to 54 hours, but you record the average of your 2 inventory readings at the beginning of the test. Then you record the average of your 2 inventory readings at the end of this test. And then you compare that difference with the standards that you see on that chart on page 54. You have to repeat that weekly standard each week in the month. So you're going to do a weekly test for four times in that month. And then you're going to average those 4 weeks of tests that you got for the weekly test and compare that with the monthly standard that you can see on page 50, on that graph on page 54. And again, you got to report all suspected releases. So you have a suspected release using this when your weekly or your monthly test exceeds the numbers that you're going to see in that chart on 54. If you get a failing result, it must be reported to ADEQ within 24 hours of you getting that report. Manual tank gauging. One more time. The tank, to use this method, the tank has to be below 2,000 gallons. You can use manual tank gauging with tank tightness testing if the tank is between 1,000 and 2,000 gallons. You can use it for 10 years with the tank tightness test in the middle of that 10-year period every 5 years. If the tank is less than 1,000 gallons, you can use that method for the life of the tank. If the tank is greater than 2,000 gallons, you can't use this method at all. So, manual tank gauging. You can only use it for 10 years for tanks that are larger than 1,000 and not more than 2,000 gallons. And you got to meet both the weekly and the monthly standard has to be met for you to pass this form of release detection. All right, so now that's the end of the release detections for the tank. Now we're going to talk about release detection for the piping that's actually out there. There's two types of piping systems for underground storage tank facilities: pressurized and suction piping. Release detection for each one of these methods differs, and you have to know the difference. If you have pressurized piping at your facility, it requires two forms of leak detection. You have to have one from column A, and this is the automatic line leak detector, and you have to choose one from column B. If you're using monthly monitoring as a method for your release detection, then it's a no-brainer that you're going to continue to use your monthly monitoring to satisfy column B. If you have a submersible turbine pump head for your pressurized piping, then you're going to have an electronic or an automatic line leak detector that's going to be on that submersible turbine pump head, and that's going to satisfy what you need for column A. So that's how you're going to take care. Now, if you're not using one of these monthly methods, then you can do an annual line tightness test to satisfy B. Two forms of release detection, pressurized piping, one from A and one from B. If you have pressurized piping, you have a submersible turbine pump, and the submersible turbine pump, it pushes product to your dispenser. The STP, the submersible turbine pump head, is in a sump up above your tank. This is what a submersible turbine pump looks like, cutaway view. This is what it looks like when you're looking down on top of your tank. Submersible turbine pump head. Pressurized piping. Pushing product to the dispenser. More submersible turbine pump heads sitting directly up above the tank. See each one of them here. Pressurized pipe. On top of that submersible turbine pump head is the automatic or electronic line leak detectors. And that's what we showed. This is going to take care of column A over there. Okay? So there are two types of automatic line leak detectors. You can have a mechanical one, or you can have an electronic automatic line leak detector. The mechanical has pressure valves that test for leaks each time that you pump the gas. If you have the electronic sensors, they communicate with your automatic tank gauge control panel. And they're going to notify you of that leak rate, which is 3.0 gallons per hour. If you have mechanical automatic line leak detectors, they have to be tested at least every 12 months. The electronic line leak detectors, they are tested continuously, so they don't need to be tested. If your automatic line leak detectors don't perform according to the manufacturer's specifications, you got to replace them. And when you're required to do this test once every year on your automatic line leak detectors, you have to keep the test results for at least 1 year. So if you have electronic line leak detectors, the electronic line leak detectors, they communicate with the automatic tank gauge console at your facility. They're capable of detecting, again, 3.0 gallon per hour leak rate for your electronic or automatic line leak detectors, and that is the catastrophic line leak rate, 3.0 gallons per hour. The electronic ones, they perform continuous checks. They're continuously checking for that line leak rate of 3.0 gallons per hour. So these electronic line leak detectors, they must be programmed to shut down that submersible turbine pump head whenever that catastrophic line leak is detected. That's the last thing you want to do, is to have that submersible turbine pump head keep pumping when you've detected that you got a leak that's greater than 3 gallons an hour. So automatic and electronic line leak detectors, they shut off that submersible turbine pump head when they reach that leak rate. And this is what the automatic or electronic line leak detectors look like sitting on top of that submersible turbine pump head. You can see some more. They're normally found on the submersible turbine pump head in the sump up above the tank. And so here's some more pictures of the automatic line leak detectors. And you can see them right here in yellow circled. That's what they look like. So this is taking care of column A for your first form of release detection for pressurized piping. It's a no-brainer because these automatic and electronic line leak detectors come with the submersible turbine pump heads. So there's your A portion of taking care of one form. And remember, pressurized piping, you have to have two forms of leak detection. First, in column B, you can do an annual line tightness test. So one test every 12 months where you can have somebody come out and do that line tightness test. That'll satisfy B. Or you don't have to do that if you use one of those monthly test methods that we talked about for an hour after the break. So, and here's the line tightness test. And basically on these line tightness tests, when they do them, they set up a vacuum on your system. It's a little more complicated than that, but they just see if you can hold that vacuum. If you can hold that vacuum, then the system tests tight. Or you can use one of the other ones. Remember, column B, the annual tightness test once every 12 months. Or you can do one of those monthly forms of monitoring. And you know, if you're using one of those monthlies already for your tank, you're going to be using it for your pressurized pipe also. While we're talking about automatic and electronic line leak detectors, you can see a picture here of a shear valve. And the shear valves are set up to go right at the bottom of your dispenser on your dispenser island. They're set so in case somebody gets a little rambunctious, jumps over your island and smacks your dispenser, these valves will shear. And when these valves shear, they automatically close the valve at the bottom of your dispenser. So they work similar to your automatic and electronic line leak detectors is they shut down the submersible turbine pump head, whereas the shear valve will actually close that valve. Now, if you've got suction systems pulls the product from the tank. Instead of pushing, they're pulling. You have pulleys and belts are inside your dispenser. That's another way that you can tell whether you have suction piping. There's no submersible turbine pump head in a sump up above the tank if you've got suction piping. Suction piping, this is basically what we're talking about, pulleys and belts inside the dispensers. If you have safe suction piping, and safe suction piping is this, if your lines are sloped back to your tank and you have only one check valve, and that only one check valve is right below the dispenser, then you've got safe suction. If you've got safe suction, leak detection is not required for suction piping. If you have some other configuration of suction piping, then you have to do leak detection. And it differs from pressurized piping in the fact that in this case, without safe suction piping, you have to do one form of release detection. Instead of two, like for pressurized piping, one form of release detection for suction piping if it's not safe suction piping. And that is you have to do a line tightness test every 3 years for suction piping. Or you can use one of those monthly monitoring methods that we talked about for an hour after the first break. Vapor, groundwater, interstitial, or statistical inventory reconciliation. So you only have to do one if you got suction piping and it's not safe suction piping. So the difference between pressurized piping and suction piping is that pressurized piping requires two forms of leak detection. Suction piping does not require leak detection if it meets the safe suction requirement. If it doesn't meet the safe suction requirement, it only requires one form of leak detection. Piping that's associated with an emergency generator tank is not required to have leak detection. It applies only to emergency generator tanks that were in the ground prior to July 1, 2007. They're deferred from release detection. Any emergency generator tank put into the ground after July 1, 2007, release detection is required. So we already talked about this earlier today too. New piping installations and existing piping replacements. But this time we're putting in that 5 feet in there. So if you're replacing more than 5 feet in its single wall pipe, you must replace it with piping that's secondarily contained and a way to monitor the interstitial space. So you need to know what kind of leak detection that you have at your facilities for both your tanks and for your piping. You have to know whether you have pressurized or suction pipe at your facility. And you need to know the requirements. Do you know how long you must keep your leak detection records? One more time, you got to keep them for 12 months. You have to do your leak detection once a month. Last 12 months of records, one time a month is required. Do you know when you must report a suspected release? If you think that you've got a suspected release, call, but 24 hours is the number. If you have a release at your facility, you need to know what to do to handling that release. Now, pay close attention to this in yellow here, subsurface. You have to report, respond to, and investigate all subsurface suspected or confirmed releases of any amount. Any amount. When you see this on the test, it's going to look like that for sure is the wrong answer. If it's subsurface, how are you going to know how much that you've released? You're not going to know. So any subsurface release of any amount. You have to report any spill or any overfill that is greater than 25 gallons. You have to report surface spills of any amount, but in this case, that cannot be cleaned up within 24 hours. Surface releases of any amount that can't be cleaned up within 24 hours. You have to report all suspected or confirmed releases to the department within 24 hours. This includes, generally, you can suspect a release in any of these methods right here. You have unusual operating conditions at your facility, meaning all of a sudden you have a sudden loss of product in your tank. It's a suspected release. If your dispensing equipment starts acting erratically, you got a suspected release. If you have unexplained water in the tank, you get a big jump of water inside your tank whenever you're sticking your tank, suspected release. Or, as we talked about earlier, if you're walking around your facility and you can smell vapors that you generally don't smell, or you can see a sheen on any of the water that's in ditches in proximity to your facility, there's a sheen on that water, suspected release. Or any of your leak detection methods indicates that you've had a release. So good, report them within 24 hours. Don't let that be the way to keep you from using the Petroleum Storage Tank Trust Fund. So if you have a confirmed release at your facility, you got to stop it Then you got to contain it. Then you got to mitigate any fire or any explosion hazards. And you got to notify us within 24 hours. I know it seems redundant, but it's really important, that 24 hour. We'll get to that here in a minute. So if you have a confirmed release, ADEQ is notified. We'll determine any further actions that we want you to do for that confirmed release. That confirmed release, what we might ask you to do is a site assessment or an investigation at your site, or we might ask you to do a corrective action plan. It pretty much says it all here, dollar signs. It's in your best interest to keep any leak that you have at your facility as small as possible. It costs big bucks to remediate the soil or the groundwater that you contaminate. Most frequent violations for underground storage tank operators. Most frequent violations. Failure to test your cathodic protection systems. Remember, within 6 months of installation or repair, and then within every 3 years. So if you have to do corrosion protection, you got to test it. Have your leak detection records. You know, where's your July 2011 monthly release detection record? You know where it is today? If you don't know where it is, you better find out where it is and put it all together in a book. You need to have those release detection records. If you have pressurized piping system, have you tested your automatic line leak detectors? If you're required to do an annual line tightness test, have you done that? Do you have the records to show that you've done that? Have you reported any suspected releases? If you've had them, I hope you've done that. So, out of those violations, they can be very costly to you, and they could result in delivery prohibition. Delivery prohibition is red tagging. Red tagging can occur immediately at your facility for failure for you to be equipped to comply with release detection, overfill protection, and corrosion protection if it's needed. You can also be red tagged if you fail to properly maintain compliance with these same things: release, spill, overfill, or corrosion protection, or if you can't meet your financial responsibility. That's what it looks like on your fill pipe. And if this happens at your facility, then you get to come back to this class and do this little glorious little session again within 45 days. So once you're certified here today and you're not red tagged, then this certification will go on forever. All right, we got just a little bit to go here, and what we got left here, a lot of test questions are on these last 5 or 6 minutes here of slides. So, you know, if you're fading, hang on. We'll get you through it. Financial responsibility. Financial responsibility is the amount for which you are responsible as the owner or operator of an underground storage tank facility. It includes what you're responsible for when it comes up to corrective action if you've had a spill or release. It also has to do about third-party liability if you've had a spill or release and your neighbor sues you for contaminating their drinking water source. And we're going to talk about the mechanisms that you can use to show that you have that financial responsibility. And those mechanisms are the Petroleum Storage Tank Trust Fund. You can have insurance coverage, you can have a guarantee, you can have a surety bond, you can have a letter of credit. You can also have an insurance pool, you can pass a financial test that you can see in 40 CFR 280. You can use a standby trust fund to show your financial responsibility, or you can use a combination of all of these mechanisms to show that you have financial responsibility. Now, that financial responsibility is, if you're an oil marketer, you have to show financial responsibility for $1 million per occurrence, a release at your facility, $1 million. You have to show financial responsibility for $1 million aggregate. And if you've got more than 100 tanks, then you have to show you have financial responsibility for $2 million. If you're a non-marketer and you're doing below 10,000 gallons of gas monthly through your facility, then it's basically half of what it is for a marketer. So $500,000 per occurrence, $1 million aggregate coverage, or $2 million, again, if you have more than 100 tanks. If you are a non-marketer and you're doing more than 10,000 gallons on a monthly basis, then $1 million per occurrence, $1 million aggregate, and $2 million if you got more than 100 tanks. So, certification of financial responsibility requirements. You have to know what type of mechanism that you're using to satisfy your financial responsibility. Which one of those mechanisms is it? Surety bond, letter of credit, petroleum storage tank fund, petroleum storage tank trust fund. Most of you in here are going to be using that petroleum storage tank trust fund. So then you have to know how much is that coverage that you have, whichever mechanism that you're actually using. And then the next thing that's important is the effective period of that coverage. It's just like, you know, when the cops pull you over, they're going to look to see if you've got insurance coverage, and then they're going to see how long does this coverage last. And the same here with the financial responsibility requirements, effective period of coverage. So you got to know the type of mechanism that you're using to meet your financial responsibility, the amount of that coverage, and then the effective period of that coverage. So if you're going to use the Petroleum Storage Tank Trust Fund, pretty simple hoops to jump through here, boys and girls. You have to register each tank. You have to pay your required annual tank fees. You have to report those releases in a timely manner within 24 hours of you knowing that you had one or suspected one. And then you have to cooperate with this department on any corrective action that we want you to do. And so, you know, you need to smile and act like that it was a grand idea if we ask you to do something, and then you can wait until we get in our car and move down the street, and then you can call us or do whatever you want to do to us as we're away. But while we're there, you need to cooperate with us. That's all you got to use to get into the Petroleum Storage Tank Trust Fund. With the exception of $7,500 has to come out of your pocket for corrective action. It's kind of like a deductible. $7,500, if it's required, has to come out of your pocket for third-party liabilities. And so here we're talking about you're paying your fees, you're registering your tanks, you're cooperating with us. You just spent $15,000 in a deductible, and the Petroleum Storage Tank Trust Fund will give you up to $1.5 million per occurrence for any corrective action that's required at your facility, and we'll give you up to $1 million per occurrence for any third-party liabilities. So we're not asking you to do a whole lot. 15 grand out of your pocket, $2.5 million could come to you if you need it. So don't let not getting on that phone within that 24-hour period keep you from getting that money. So that's why I said, you know, little boy and wolf, you know, you see something that's hairy out there in the distance. You get on the phone and call us, it's a suspected release. So you can use the Petroleum Storage Tank Trust Fund for above ground tanks in the 1320 up to 40,000 gallons. Underground tanks, 110 gallons or larger, can use the Petroleum Storage Tank Trust Fund. Now, they have to be holding a regulated substance, so gasoline, kerosene, diesel fuel, that type of thing, regulated substance to use the Petroleum Storage Tank Trust Fund. To use it, you have to meet the eligibility requirements at the time of the discovery of the release. So pay your tank fees and do it on time. Register your tank. Register your tank on time. Give us timely notice if you have a suspected release or a release. And then cooperate with anything we ask you to do if you have a release. Notification requirements. We talked about this a little bit earlier. If you have a change of ownership at your facility, you have a change of an owner or operator address of your facility, or you replace a tank or any section of piping, we've got to be notified. You have a change in service where you have a closure or a temporary closure at your facility, we've got to be notified. Notification form, little booklet here, there's nothing to it. Any of those things take place, we have to be notified. We'll send you this form. You can fill this form out. And that's why I said, when we talked about what you have at your facility from your last inspection report, if what you have on your last inspection report is not what you have at your facility, then you didn't notify us of any changes that took place since that. So, you know, you need to keep us abreast of anything that's going on at your facility. Any repair records that you have must be maintained. Any repair records must be maintained for the life of your UST system. Any repairs can be made to fiberglass tanks if they're done by the manufacturer's rep or according to the manufacturer's specs. Fiberglass tank repairs can be done. Fiberglass pipe and fittings may be repaired as long as they're done according to the manufacturer's specifications. If you have metal piping sections and fittings that have leaked, got to be scrapped. You got to pitch them. They have to be replaced. Metal piping or fittings that have leaked must be pitched. They have to be replaced. We've talked about this, very limited amount of piping repairs. Remember that 5 feet. May be done without triggering replacement requirements if the piping is single wall. We're talking about secondary containment with interstitial monitoring. Anything more than 5 feet. Record keeping, records that you must keep. One more time, leak detection records. How long you got to keep them? How about 12 months? Cathodic protection. It has to be done every 3 years. If you're using sacrificial anode protection, you got to keep it until the next test. Any repair records, we just went through there. How long you got to keep them? Lifetime. We're going to get to closure requirements, but I'm going to tell you right now, 3 years. Any closure papers that you have, the site assessment that's done to make sure that you haven't contaminated that site before it's closed, 3 years. Performance claims. Any performance claims that are out there made by any of the manufacturers, they have to be kept for at least 5 years. You people that have automatic tank gauges, no, it's not good record keeping. You know, where's July 2011? That's over there on the counter. Not good record keeping. All right, now to place a tank temporarily out of service. Temporarily out of service. You have to file an amended notification form, that little form I showed you. Call us, we'll send you one. Say that we're going to be temporarily out of service. That tank, you have to keep corrosion protection systems operational, and you got to continue to monitor them if it's required for that temporarily out of service tank. Your monthly leak detection is still required. Temporarily out of service. You got to keep the vent lines at a temporarily out of service. You have to keep those vent lines open. And how high do they have to be? 12 feet above the ground. If you're going to be temporarily out of service period is longer than 3 months, all other pipes, lines, manways, and any other ancillary equipment associated with the UST has to be closed by capping and securing. More than 3 months, temporarily out of service. If your tank is temporarily out of service, you have to empty it to no more than 1 inch of residue. Now, when you empty this tank, what do you do with the stuff that was in that tank? You send it to a fuel blender or a recycler, and they'll take care of this stuff that you've got right here. Also, if you see sometime later today, a temporarily out of service tank is a tank that does not meet the requirements for final closure. Does not meet the state or federal requirements if it's temporarily out of service. That tank does not meet what's required federally or state-wise to be permanently closed. If your UST is not empty, you need to continue to meet your monthly leak detection for both the tank and the piping. So it's another good reason, pump this stuff out, send it to the fuel blender or recycler. If you have a new or upgraded tank, it can remain temporarily out of service as long as the cathodic protection and leak detection are maintained. Temporarily out of service forever. You have to treat any releases from a temporarily closed system just like it was a system that's currently in use. If you're going to permanently close your facility, you have to notify us at least 30 days prior to the permanent closing. Then you have to determine if there was any contamination in the surrounding environment has taken place at your facility. So you're required to do a site assessment if you want to permanently close. A site assessment will be required to be done prior to closures when you're closing the tank in place. If the tanks are removed, the site assessment must be performed before permanent closure is approved. You must maintain a record after you close, and you do this site assessment that shows that you have no contamination around your tanks at that facility. You have to keep those records for at least 3 years, and that's it. We're done.